An object of mass m on a string is whirled with increasing speed in a horizontal circle as shown above. When the string breaks, the object has speed v0 and the circular path has radius r and is a height h above the ground. Neglect air friction. A bit. Determine the following, expressing all answers in terms of h, v0 and g. First one. The time required for the object to hit the ground after the string breaks. Second bit. The horizontal distance the object travels from the time the string breaks until it hits the ground. Third bit. The speed of the object just before it hits the ground. B bit. On the figure below, draw and label all the forces acting on the object when it is in the position shown in the diagram above. C bit. Determine the tension in the string just before the string breaks. Express your answer in terms of M, R, V0, and G. Obviously, this FRQ is based on uniform circular motion. Here he is asking us to draw the free body diagram for the object when it is here. Okay, that point is given to us. Therefore, the tension is acting in this direction. The person is holding the object with the string. The object is tied to the string and the person is whirling the object. Therefore, the tension is acting along the string and then gravity acting downwards. These are the forces acting on it. Obviously, the tension is making an angle theta with the horizontal. Therefore, it has both the x component and y component. X component is ftx and then y component is fty, and ftx is equal to ft cos theta because the x component is adjacent to the angle now. Therefore, we have to take the cos component. And then fty is the opposite side of the angle. Therefore, this is ft sin theta. This is from the geometry of the figure. Now, he is asking us to find the time required for the object to hit the ground. Why it will hit? The string breaks in between. Okay, while whirling, at one point of time, the string breaks. When the string breaks, the object falls down. So when the object is falling down, we have to find out the time taken by the object to drop the height h, and then the horizontal distance it travels from the point it leaves the circle, and then the speed with which it hits the ground. These three quantities we have to find out. So here delta y is the height h. Okay. So we use the kinematic equation. So this is an integrated problem. Therefore, we have to use the first one is kinematic equation. Kinematic equation delta y is equal to VI by t plus half AT square. Here delta y is the h height and then VI y is equal to 0 because the y component is 0 because the object is making a horizontal circle, not the vertical circle. So horizontal circle, therefore the velocity, whatever velocity the object has is the horizontal velocity, not the vertical velocity. Therefore, the vertical velocity, initial vertical velocity is 0, and then acceleration is, the object is under the free fall. The moment the string breaks, the object is under free fall. Therefore, the acceleration is the free fall acceleration. That means acceleration due to gravity. So substituting these quantities in the kinematic equation delta y is equal to VI by t plus half AT square, we will calculate t. T is equal to square root of 2h by g. Next, we have to find out how much distance, horizontal distance, the object travels while falling. For that, delta x is equal to Vt, and then V is equal to V0, and then T is equal to square root of 2h by g. Just now we calculated. Therefore, delta x or the horizontal distance traveled by the object is equal to V0 times square root of 2h by g. And then the third one is, what is the speed with which it hits the ground? For that, we have to find out both the x component and y component, and then we have to take the the total one, total velocity. That means with the component, we will get the components, x component and y component, but he is asking the final velocity. So we have to take the square root. That means both velocities are vector quantities. No, we have to add the x component and y component so that we get the final velocity. Here Vx is equal to V naught and Vy is equal to Viy plus Gt. That means this equation is Vy is equal to Vi. Here I write this one. This equation I got from the kinematic equation. Vy is equal to, or V is equal to, Vy is equal to, I write like this, Vy is equal to, this is final velocity, Vfy, I write, maybe that way you will be comfortable. Vfy is equal to Viy plus At. This equation you know, no? Vf is equal to Vi plus At. Vf is equal to Vi plus At. So from this equation, I got this equation. From this equation, I am substituting for g, free fall acceleration. From that, I am calculating the Vy. Okay, final velocity. So Vy is equal to square root of 2gh because Vy square, then from this I will calculate Vy square is equal to 2gh. Here, Vx is equal to V naught because the x component will not change. No force is acting along the x direction. Therefore, Vix is equal to, I write here, Vix is equal to Vfx is equal to V naught since no force acts on it. No force acting along the x direction. Whereas along the y direction, gravity is acting, therefore the final velocity will be different from the initial velocity. Initial velocity is 0, but the final velocity is square root of 2gh. Okay, but x component will not change. Now that total velocity v is equal to square root of vx square plus vy square. So that is v naught square plus 2gh square root of. Okay. This is the final velocity of the velocity with which the object hits the ground. Next, determine the tension in the string just before the string breaks. So for that, what we have to do, I will take the y component. I will write the force equation for the x component and y component. So sigma Fy is equal to Ft sine theta minus Fg is equal to 0. So here, if you see this one, here, this is the y component. So y component is upward direction and then downward direction, gravity is acting. Am I right? So therefore, sigma Fy is equal to Ft sine theta minus Fg is equal to 0 or Ft sine theta is equal to Fg. So next, when we take the x component, the x component of the tension contributes to the centripetal force. Therefore, Ft sine theta is equal to Fc. Okay, now we have two equations. Ft cos theta is equal to mv naught square over r, and then Ft sin theta is equal to mg, because we know Fg is equal to mg and Fc is equal to mv naught square over r. Okay, now from with these two equations, I have to find out the Ft. So for that, what I do is I will square and add both equation 1 and 2, and then simplify. After simplification, I will get Ft is equal to m square root of v naught to the power of 4 by r square plus g square. Just to go through the simplification. Simple algebraic simplification, nothing beyond that. We know cos square theta plus sin square theta is equal to 1. Trigonometric equality that I took here. So here, if you take this one, ft square cos square theta plus ft square sin square theta. Okay, so this is equal to ft square cos square theta plus sin square theta. And cos square theta plus sin square theta is equal to 1. Therefore, this will become ft square. That is how I got this ft square. And then right hand square, you have to do the simplification. That's it. Nothing beyond that. Here, the left hand side, you may have this doubt. That is why I elaborated this one. Okay. So this is the ft square. Understood. Hope this helps. Thank you. Bye bye.